Imagine a wooden vessel so advanced that it conquered 3 continents, crossed uncharted oceans, and brought Europe face to face with the unknown. While other nations hugged coastlines in fear, Portuguese shipbuilders were crafting floating fortresses that would rewrite the map of the world. These weren't just ships, they were the Renaissance's equivalent of spacecraft, engineered with secrets that took centuries to perfect. Today, I'm taking you inside the workshops where history's greatest maritime empire was literally built, plank by plank. Before we dive into the shipyards of discovery, hit that subscribe button and smash the like. Trust me, what you're about to learn will change how you see every maritime movie forever. Let me take you back to where this story really begins, because you can't understand how Portuguese ships conquered the world without knowing what came before them. When I first started researching Portuguese shipbuilding, I was shocked to discover that their revolution didn't happen in a vacuum. The Portuguese were brilliant at taking existing technologies and pushing them to their absolute limits. They were the ultimate innovators, standing on the shoulders of maritime giants who came centuries before. Think about the Iberian Peninsula's unique position. For thousands of years, this was where civilizations collided. The Phoenicians sailed here. The Romans conquered here. The Moors ruled here for centuries. Every single one of these cultures left their maritime DNA in Portuguese waters. The Romans gave Portugal its first taste of sophisticated naval architecture. Roman galleys weren't just boats, they were engineering marvels. These vessels used a technique called mortise and tenon joinery, where wooden pegs locked planks together with incredible precision. I'm talking about woodworking so exact that some Roman shipwrecks, discovered after 2,000 years underwater, still have joints that fit together perfectly. But here's what's fascinating. The Romans built their ships shell first. They'd construct the outer hull first, then add the internal skeleton afterward. It was backward from what you might expect, but it created incredibly strong, watertight vessels. Portuguese shipwrights would later revolutionize this entire approach. Then came the Islamic period, and this is where things get really interesting. When the Moors controlled much of Iberia, from the 8th to the 13th centuries, they brought with them knowledge from across the Mediterranean and even from the Indian Ocean. They understood lateen sails, those triangular sails that could catch wind from almost any direction. This technology was absolutely game-changing. I need you to understand how revolutionary lateen sails were. Before them, European ships used square sails that only worked well when the wind was directly behind you. With lateen sails, suddenly you could sail into the wind, tacking back and forth. You weren't at the mercy of weather anymore. You had control. The Portuguese observed all of this. They absorbed it. And when the Reconquista finally ended in the Iberian Peninsula, they didn't just kick out the Moors, they kept their maritime knowledge. This is crucial. While other European nations were stuck in medieval shipbuilding traditions, the Portuguese were already synthesizing centuries of Mediterranean wisdom. By the early 1400s, Portugal was this tiny kingdom on the edge of Europe with a massive problem. They were landlocked by Spain on one side and faced an enormous, terrifying ocean on the other. They couldn't expand east. The only way forward was west and south, into waters that medieval maps literally marked with "Here be dragons." Ubi, Prince Henry the Navigator, and yes, I know historians debate whether he actually navigated anything himself, established a center of maritime innovation at Sagres. This wasn't just a navigation school. It was where cartographers, shipbuilders, astronomers, and sailors all worked together. Imagine it as a medieval NASA, but focused entirely on conquering the ocean. The genius of the Portuguese wasn't inventing everything from scratch. It was their ability to recognize good ideas from everywhere. Viking clinker-built hulls, Mediterranean lateen sails, Islamic astronomy, Italian financial systems, and combine them into something entirely new. They started experimenting with hybrid designs. What if we took the sturdy Atlantic hull designs of Northern Europe and combined them with the maneuverable sail plans of the Mediterranean? What if we built ships specifically designed for exploration, not just fishing or warfare? This experimentation would lead directly to Portugal's secret weapon, the ship that would change everything. But before we get there, I need to emphasize something important. Portuguese shipbuilding wasn't just about technical innovation. It was about creating a complete system, from timber selection to crew training, from financial backing to religious justification for exploration. The Portuguese crown understood something that other nations didn't. Controlling ship technology meant controlling global trade. So they invested heavily, they protected their secrets fiercely, and they created an entire infrastructure around building the world's best vessels. Medieval Portuguese shipyards were already producing barges for coastal trade, fishing boats that could handle Atlantic swells, and small military vessels. But all of this was just the warm-up. The real revolution was about to begin. Now we come to the ship that made everything possible, the caravel. If the Portuguese Age of Discovery was a movie, the caravel would be the main character. I want you to picture this. It's the early 1400s, and European ships are basically of two types. You have the sturdy, round-hulled cogs of Northern Europe, great for carrying cargo but slow and difficult to maneuver. Then you have the Mediterranean galleys, fast and maneuverable, but requiring massive crews of rowers and unsuitable for long ocean voyages. The Portuguese looked at this situation and said, what if we create something completely different? The caravel emerged sometime in the 1430s, and I need to emphasize how radical this design was. When I first studied caravel specifications, I was amazed at how modern the thinking was. These shipwrights were solving problems that wouldn't be fully understood mathematically for another 2 centuries. Let me describe what made caravels special. First, they were small, typically 50 to 70 feet long, with a displacement of only 50 to 60 tons. In an era when bigger was considered better, the Portuguese went deliberately small. This wasn't a compromise, it was a strategic choice. Small size meant several things. Fewer crew members needed, which meant provisions could last longer. Less deep draft, which meant you could sail into shallow rivers and approach coastlines that larger ships couldn't reach. More affordable to build, which meant more ships could be constructed, and crucially, easier to handle in storm conditions with a small crew. But size wasn't the revolutionary part. It was the hull design and sail configuration that changed everything. Portuguese shipwrights developed a hull that was longer and narrower than traditional ships, with a much sharper bow. I'm talking about length-to-beam ratios of around 3.1 or even 4.1 compared to the 2:1 ratios of medieval cogs. This made caravels incredibly fast and able to sail much closer to the wind. The hull construction used a technique called carvel-built planking, and yes, the similarity to caravel is not coincidental. Instead of overlapping planks like Viking longships, caravel planks were fitted edge to edge, creating a smooth hull surface. This reduced drag dramatically and made the ships faster and more watertight. Now, let's talk about the sails, because this is where the genius really shows. Early caravels used 2 or 3 lateen sails, those triangular sails I mentioned earlier. But here's what's brilliant. The Portuguese rigged them in a way that gave unprecedented control. With lateen sails, a caravel could sail within 60 degrees of the wind direction. Let me put that in perspective. Most medieval ships could only sail with the wind behind them or slightly to the side. Caravels could sail almost directly into the wind by tacking back and forth. This meant they could explore coastlines systematically, could return home even if wind patterns changed, and weren't trapped by seasonal weather patterns. The Portuguese experimented constantly with sail configurations. Some caravels used pure lateen rigging. These were called caravella latina. Others mixed lateen sails with square sails, called caravella redonda. This flexibility meant the same ship could be optimized for different conditions. But here's something that doesn't get talked about enough. Caravels were also incredibly sturdy for their size. Portuguese shipwrights used curved ribs placed close together, sometimes less than 2 feet apart, creating a flexible but strong skeleton. The hull could literally bend with ocean swells without breaking. I've seen replicas of caravels, and when you stand next to one, you realize how small they actually were. Bartolomeu Dias rounded the Cape of Good Hope, one of the most dangerous passages on Earth, in ships that would fit in a modern basketball court. That's insane when you think about it. The Portuguese also incorporated something else into caravel design. They were designed to be beached. Unlike larger ships that needed deep water ports, caravels could be sailed right up onto beaches. This meant crews could careen them, turn them on their sides to scrape off barnacles and repair damage without needing shipyard facilities. In uncharted territories, this was invaluable. Inside, caravels were Spartan. There was a small cabin at the stern for the captain and perhaps a pilot, but most of the crew slept on deck or in the hold. There was a simple, brick-lined firebox for cooking. Imagine trying to maintain a fire on a wooden ship in the middle of the Atlantic. Storage was designed to maximize space for provisions, water, and trade goods. Navigation equipment on caravels was surprisingly sophisticated. They carried astrolabes for measuring the sun's angle, compasses, hourglasses for timing, and cross-staffs for celestial navigation. The Portuguese developed practical navigation tables that made astronomical navigation possible for ordinary sailors, not just scholars. Caravels weren't armed heavily, maybe a few small cannons called falconets, because they were designed for exploration, not conquest. Speed and maneuverability were their defense. If they encountered hostile ships, they could usually outrun them. The most famous caravel is probably the Niña from Columbus's expedition. Yes, Columbus used Portuguese ship designs because they were simply the best available. But Portuguese explorers used caravels to map the entire African coast, to discover the route to India, and to explore Brazil. By the time Vasco da Gama rounded Africa and reached India in 1498, Portuguese caravels had sailed further than any European ships in history. They'd proven that systematic exploration was possible, that the Atlantic could be crossed reliably, and that small, well-designed ships could survive conditions that would destroy larger vessels. The caravel represented something profound. It proved that superior design and craftsmanship could overcome size and power. It was Portugal's answer to having limited resources but unlimited ambition. Here's something that blew my mind when I first learned about it. Building a Portuguese ship began years before the first plank was laid. It started in forests across Europe and the Mediterranean, with master shipwrights searching for the perfect trees. If you think timber is just timber, you're missing one of the most fascinating aspects of historical shipbuilding. The Portuguese were absolutely obsessive about wood selection, and for good reason. Choosing the wrong timber could mean the difference between a ship that lasted decades and one that sank on its maiden voyage. Let me walk you through what Portuguese shipwrights were looking for. For the keel, the spine of the ship that everything else attaches to, you needed oak. Not just any oak, but mature trees that were perfectly straight, at least 40 to 50 feet long, with minimal defects. Finding single trees that met these requirements was incredibly difficult. Sometimes shipwrights would search for years to find the perfect keel timber. Portuguese oak, especially from the regions around Lisbon and Porto, was prized because it grew slowly in the Mediterranean climate, creating dense, durable wood. But Portugal didn't have unlimited forests, so they also imported oak from northern Spain, France, and even the Baltic regions. Here's where it gets interesting. For curved pieces, the ribs and frames that give ships their shape, shipwrights didn't cut curves from straight wood. That would weaken the grain and create points of failure. Instead, They searched forests for trees that naturally grew in the shapes they needed. I'm talking about trees growing on hillsides that developed natural curves, or trees where branches met the trunk at specific angles. Master shipwrights would actually mark trees in forests years before they needed them, essentially reserving naturally curved timber for future ships. This practice, called compass timber, was an art form. A skilled shipwright could look at a forest and see ships hidden in the trees. They understood wood grain, growth patterns, and structural integrity in ways that would put modern engineers to shame. Pine was crucial too, particularly for planking and decking. Maritime pine from Portugal's coastal forests was ideal. It was flexible enough to bend when needed, but strong enough to withstand the constant stress of ocean voyages. Pine also had natural resins that helped repel water and resist rot. For masts and yards, the spars that held the sails, shipwrights needed tall, straight trees with consistent grain. Pine was often used, but for larger ships, Portuguese builders imported fir and spruce from northern Europe. The Baltic regions were famous for producing the best mast timber in the world. But here's what's crazy. Transporting this timber was itself a major undertaking. Logs were floated down rivers to coastal cities, shipped across the Mediterranean, or hauled by ox cart for hundreds of miles. Some of the timber used in Portuguese ships traveled further than the ships themselves would sail. Seasoning the timber was another critical process that's often overlooked. Green wood, freshly cut, contains too much moisture and will warp and crack as it dries. Portuguese shipwrights understood that timber needed to be aged for at least 2 to 3 years before use. They developed elaborate systems for seasoning wood. Logs were stored in covered but well-ventilated timber yards, sometimes partially submerged in salt water or buried in mud. These techniques slowly drew out moisture while preventing rapid drying that would cause cracks. The Portuguese crown actually maintained strategic timber reserves. Certain forests were declared royal property, and cutting trees without permission was severely punished. This wasn't just about conservation, it was about national security. Ships were military assets, and controlling timber meant controlling naval power. By the time of the Great Explorations, Portugal was facing a timber crisis. Centuries of shipbuilding had depleted local forests. This actually became one of the drivers for colonial expansion. New colonies meant new sources of timber. Brazilian hardwoods would eventually become crucial for Portuguese shipbuilding. Different woods served different purposes. Cork oak bark was used for buoyancy aids and stoppers. Hardwoods like walnut were used for decorative elements and furniture in officers' quarters. Even the choice of wood for barrels and casks was carefully considered. Chestnut for water storage, oak for wine. Shipwrights also understood that wood from different regions had different properties. Mediterranean oak was denser and more water-resistant. Northern oak was more flexible. Mixing woods from different sources in strategic ways created stronger, more durable ships. The relationship between shipbuilders and foresters was crucial. Master shipwrights often traveled to forests personally to select timber, marking trees with specific codes that indicated which ship they were destined for and which part of the ship they'd become. There's something almost spiritual about this aspect of shipbuilding. These craftsmen understood that they were transforming living trees into vessels that would carry men across oceans. The timber selection process required patience, knowledge passed down through generations, and a deep understanding of both forests and seas. When you see a beautiful historical ship, remember, its story began in a forest, with a shipwright's experienced eye identifying trees that would become immortal through their transformation into vessels of discovery. Now let me take you to the heart of Portuguese maritime power, the Ribeira das Naus in Lisbon. This wasn't just a shipyard, it was the birthplace of an empire, the place where wooden dreams became reality. The name Ribeira das Naus literally means shipyard beach, and its location was absolutely perfect. Situated along the Tagus River, right in Lisbon's downtown, it had direct access to deep water, was protected from Atlantic storms, and was close to the royal palace. The king could literally watch his ships being built. When I first learned about the scale of operations at Ribeira das Naus, I was stunned. This wasn't some small artisan workshop. At its peak during the Age of Discovery, this shipyard employed thousands of workers: shipwrights, carpenters, caulkers, riggers, sailmakers, blacksmiths, rope makers, and labourers. The shipyard stretched for hundreds of yards along the riverfront. Imagine the scene: dozens of ships in various stages of construction, enormous wooden frames rising like the skeletons of sea monsters, the constant sounds of hammering, sawing, and shouting orders in multiple languages. The organizational structure was incredibly sophisticated. The Portuguese crown established the Casa da India, essentially a government agency that controlled all aspects of maritime commerce and shipbuilding. They maintained detailed records of every ship built, every piece of timber used, and every worker employed. Master shipwrights held positions of enormous prestige and power. These weren't just craftsmen, they were engineers, architects, and artists combined. The title Mestre, Master, was earned through years of apprenticeship and demonstrated excellence. A master shipwright's word on technical matters was essentially law. Below the masters were official shipwrights, journeymen, and apprentices, a hierarchy that ensured knowledge was passed down systematically. Boys as young as 12 might begin as apprentices, spending 7 to 10 years learning the craft before becoming journeymen. The actual construction process at Ribeira das Naus followed a precise sequence that had been refined over generations. Let me walk you through how a ship was born. First, the keel was laid. This was often accompanied by religious ceremonies. Priests would bless the keel, prayers would be offered, and sometimes coins or religious medals were placed under it for good luck. The Portuguese were deeply religious, and they viewed shipbuilding as sacred work. The keel was positioned on wooden blocks that held it at the perfect angle. Getting this exactly right was crucial because every subsequent piece would reference the keel's position. Master shipwrights used specialized tools, long wooden straightedges, plumb lines, and measuring rods to ensure perfection. Next came the frames, the ribs that would give the ship its shape. This is where the artistry really showed. Shipwrights worked from models and drawings, but much of the process was guided by experience and eye. They understood hull shapes intuitively, knowing how curves would affect speed, stability, and capacity. Frames were erected one by one, carefully spaced and temporarily braced to maintain their positions. Workers would scramble over these wooden skeletons like ants, fitting pieces together, driving wooden pegs called tree nails to hold joints, and constantly checking measurements. The backbone of the ship, the keel, stern post, and stem post, had to be absolutely precise. These pieces were joined using complex scarf joints, where wood pieces overlapped in carefully cut angles and were secured with iron bolts and wooden pegs. These joints had to be watertight and strong enough to withstand every stress the ocean could throw at them. Planking came next, and this required incredible skill. Each plank had to be shaped to follow the hull's curves, fitted tightly against its neighbors, and secured to the frames. Shipwrights would heat planks over fires or steam them in special boxes to make the wood pliable enough to bend. I need you to understand the precision involved. Planks had to fit so tightly that when you ran your hand along the hull, you couldn't feel the seams. Any gap would leak. Any misalignment would create drag or weak points. Caulking, sealing the seams between planks, was its own specialized trade. Workers called caulkers would drive oakum, tarred rope fibers, into seams using special chisels and mallets, then seal everything with pitch or tar. The rhythmic hammering of caulkers became the heartbeat of any shipyard. The Ribeira das Naus had specialized workshops surrounding the main construction areas. Rope walks, incredibly long buildings where rope was twisted, stretched for hundreds of feet. A single large ship might need miles of rope in various thicknesses. Sail lofts were huge open spaces where sailmakers stitched together massive sheets of canvas. These craftsmen were artists in their own right, understanding wind dynamics and how sail shapes affected performance. They'd reinforce stress points, add reef points for reducing sail area in storms, and create sails that could last years under brutal conditions. Blacksmith forges produced thousands of components: iron bolts, nails, anchor chains, cannon mounts, hinges, and decorative metalwork. The ringing of hammers on anvils was constant, and smoke from the forges created a perpetual haze over the shipyard. The Portuguese crown maintained strict quality control. Royal inspectors would examine work at various stages, and substandard work was rejected. This wasn't just about pride. Ships represented enormous investments, and failure at sea could mean not just lost vessels, but lost colonies, lost trade routes, and lost lives. Launching a completed ship was a major event. The entire city would turn out to watch as a new vessel slid down greased ramps into the Tagus. These launches were accompanied by celebrations, religious ceremonies, and often the presence of royalty. But the shipyard wasn't just about building new vessels. It was also where damaged ships returned for repairs, where vessels were refitted for new voyages, and where innovations were tested. If a ship returned from India with successful modifications, those changes would be incorporated into new designs. The Ribeira das Naus represented Portuguese maritime power made physical. When foreign ambassadors visited Lisbon, they were often taken to the shipyard as a demonstration of Portugal's capabilities. The message was clear: we can project power anywhere in the world because we can build ships better than anyone else. Sadly, much of the original Ribeira das Naus was destroyed in the catastrophic 1755 Lisbon earthquake. But for nearly 4 centuries before that, it was the engine that drove Portuguese exploration, trade, and empire. Now we're getting into the technical brilliance that made Portuguese ships truly revolutionary. This is where craftsmanship meets innovation, where practical experience meets engineering genius. Portuguese shipwrights didn't have computer modeling or physics equations, but they understood hydrodynamics, structural mechanics, and materials science at an intuitive, practical level that's honestly jaw-dropping. Let me start with hull design, because this is where the Portuguese made some of their most significant innovations. Traditional medieval ships used a construction method called shell-first building, inherited from Roman shipbuilding. You'd build the outer hull first, fitting planks together edge to edge, then add internal frames afterward. This created strong hulls but was extremely time-consuming and required exceptional skill. Portuguese shipwrights pioneered a hybrid approach that became known as frame-first or skeleton-first construction. They'd lay the keel, erect the main frames, and then plank over this skeleton. This method was faster, required less skilled labor for basic construction, and allowed for more standardization. But here's the genius part. They maintained the strength of shell-first construction by using massive numbers of frames placed very close together, and by using sophisticated joinery techniques at critical stress points. They got the best of both worlds, speed and strength. The hull shape itself was constantly being refined. Early Portuguese ships had relatively full, round hulls, but as exploration advanced, they developed longer, narrower hulls with finer entries, sharper bows that could cut through water more efficiently. They understood something that wouldn't be mathematically proven until the 18th century. The length-to-beam ratio dramatically affects a ship's speed and sailing characteristics. Portuguese shipwrights experimented with different ratios, learning through trial and error what modern naval architects now calculate precisely. The Portuguese also innovated in keel design. They developed keels with more pronounced dead rise, the angle of the bottom relative to horizontal, which improved stability and allowed ships to sail closer to the wind. They also experimented with false keels, sacrificial outer keels that could be replaced if damaged. Rudder design was another area of innovation. Medieval ships often used side-mounted steering oars. Portuguese ships universally adopted stern-mounted rudders, attached with complex pintle and gudgeon hinges. They refined these rudders to be larger and more efficient, giving ships better control. The stern post, where the rudder attached, was engineered to withstand enormous forces. Shipwrights used compound curves and multiple pieces of timber scarfed together to create structures that could handle the torque and stress of steering large ships through storms. Deck construction was more sophisticated than you might imagine. Portuguese ships typically had multiple decks, and each served specific purposes. The lower decks housed cargo, provisions, and often ballast. Upper decks provided working space for sailors and, on military vessels, fighting platforms. These decks had to be strong enough to support weight, but also had to allow for air circulation and water drainage. Shipwrights incorporated scuppers, drainage holes, and gratings that allowed airflow while preventing people from falling through. The Portuguese were also masters of creating watertight compartments. They understood that if one area of a ship was breached, you didn't want the entire vessel to flood. Bulkheads, internal walls, divided ships into sections, improving both safety and cargo organization. Mast stepping, how masts were installed and supported, was another area of innovation. Masts were absolutely critical, and they had to withstand enormous forces. The base of the mast, called the step, was integrated into the keel structure. The mast then passed through the decks, supported at each level by massive wooden partners that distributed loads. Portuguese shipwrights developed sophisticated rigging systems. They understood the concept of distributed loading, using multiple ropes and supports to spread forces across the ship's structure rather than concentrating stress in single points. They created intricate systems of standing rigging, permanently fixed ropes that supported masts, and running rigging ropes used to adjust sails. A large Portuguese carrick might have literally miles of rope in dozens of different diameters, each specifically engineered for its purpose. Sail design was constantly evolving. Portuguese sailmakers experimented with different weaves of canvas, different patterns of reinforcement stitching, and different configurations of reef points. They understood that sails weren't just wind catchers, they were complex aerodynamic surfaces. One innovation that doesn't get enough attention: Portuguese ships incorporated much more robust pumping systems than earlier vessels. Bilge pumps that could move large volumes of water quickly were essential for long voyages. Ships leaked constantly. That was accepted, but efficient pumps meant crews could stay ahead of the water. The Portuguese also revolutionized caulking techniques. They experimented with different materials, oakum soaked in pine tar, mixtures of pitch and resin, even exotic materials from colonies. They developed specific caulking patterns that made seams more flexible and longer lasting. Below the waterline, Portuguese shipwrights applied protective coatings. They'd coat hulls with tar and pitch, sometimes mixed with animal fat, to protect against marine borers, shipworms that could destroy wooden hulls. Later, they experimented with lead sheathing and even early anti-fouling paints. The integration of defensive and offensive capabilities into merchant ship designs was another Portuguese innovation. They built ships where cargo capacity, sailing performance, and military capability were balanced. Gunports were integrated into hull designs, reinforced areas supported cannon weight, and deck structures allowed for fighting without compromising sailing ability. What amazes me is how much of this was done through empirical observation and generational knowledge transfer. Shipwrights couldn't calculate forces or model hydrodynamics, but they could observe what worked and what failed. They'd build scale models and test them. They'd modify designs incrementally and note the results. the Portuguese maintained detailed records, not just of ships built, but of their performance. They'd note sailing characteristics, cargo capacities, maintenance issues, and longevity. This data informed future designs in a continuous improvement cycle that would make modern engineers proud. They also weren't afraid to steal good ideas. When Portuguese sailors encountered different ship types in other parts of the world, Arab dhows, Chinese junks, Indian vessels, they'd study these designs and incorporate useful features. This cultural openness to innovation was itself revolutionary. By the height of the Age of Discovery, Portuguese ships represented the culmination of centuries of Mediterranean and Atlantic shipbuilding traditions, filtered through relentless innovation and practical testing in the world's harshest maritime conditions. If the caravel was Portugal's ship of exploration, the carrick was their ship of empire. These massive vessels represented the next evolution in Portuguese maritime dominance, and building them was an engineering feat that pushed 16th-century technology to its absolute limits. Let me paint a picture of what a Portuguese carrick actually was. We're talking about ships that were 100 to 120 feet long, with displacements of 400 to 600 tons. Some even reached 1,000 tons. These were the largest mobile structures most people in the Renaissance would ever see. The carrick evolved from earlier medieval merchant ships, but incorporated all the lessons Portuguese shipwrights had learned from decades of exploration. They combined Atlantic hull designs with Mediterranean rigging, added Portuguese innovations in construction, and created something that was greater than the sum of its parts. The hull of a carrick was a masterpiece of engineering. Unlike the sleek caravels, carracks were built for capacity and stability. They had high freeboards, the distance from the waterline to the deck, which prevented waves from washing over the deck and provided protection against boarding by pirates or enemies. The distinctive shape of a carrick is instantly recognizable if you've ever seen historical paintings. A rounded, bulbous hull that swelled out above the waterline, creating enormous internal volume. This shape, called tumble-home, actually had sophisticated reasoning behind it. The widest part of the hull was at or just below the waterline. Then the sides curved inward as they rose. This served multiple purposes. It increased stability by lowering the center of gravity, it made the upper deck narrower and more manageable, and it actually made the ship more defensible. Attackers trying to board had to climb inward under the overhang. Building these massive hulls required construction techniques that were scaled-up versions of caravel methods, but with critical enhancements. The keel might be made from multiple pieces scarfed together because finding a single timber 120 feet long was nearly impossible. These scarf joints had to be absolutely perfect. Any weakness in the keel could be catastrophic. The frames of a carrick were enormous timbers, sometimes a foot or more thick, shaped from compass timber. Installing these frames required coordinated teams of dozens of workers, using block and tackle systems to lift them into position. Each frame could weigh several tons. Planking a carrick required wood in massive quantities. A single large carrick might use over 2,000 individual planks, each carefully selected, shaped and fitted. The planking near the waterline was thicker, sometimes 4 to 5 inches, to withstand the constant stresses of wave action and the weight of water pressure. Carracks had multiple decks, typically 3 or 4, sometimes more. Each deck added complexity to the construction. Deck beams had to be strong enough to support not just their own weight, but also cargo, guns, provisions, and crew. The longest beams, running across the widest part of the ship, might be 40 feet long and a foot thick. The superstructure of a carrick was equally impressive. They had towering forecastles and sterncastles, multi-story structures at the bow and stern. These weren't just decorative. They served practical purposes. The forecastle provided a high fighting platform and protected the bow from waves. The stern castle housed officers' quarters, provided another fighting platform, and contained the whipstaff or tiller mechanisms that controlled the rudder. Some stern castles rose 3 or 4 stories above the main deck, creating spaces for cabins, storage, and even small chapels. Building these structures required different techniques than hull construction. They were essentially buildings constructed on top of ships, using lighter timber but complex joinery. They had to be strong enough to withstand their own weight and wind forces, but couldn't be so heavy they'd make the ship top-heavy and unstable. Masts on carracks were absolutely massive. The main mast might be 100 feet tall and 3 feet in diameter at the base. These were often built from multiple pieces scarfed and bound together because single trees of the necessary size didn't exist. Portuguese carracks typically had 3 or 4 masts. The foremast and mainmast were the primary power sources, carrying large square sails. The mizzenmast at the stern typically carried a lateen sail for balance and maneuverability. Some carracks added a 4th mast, the Bonaventure mizzen, with another lateen sail. Each mast had to be supported by an intricate web of rigging. Heavy rope stays ran from the mast tops to various points on the hull, preventing the masts from falling forward, backward, or sideways. Shrouds, ladder-like rope structures, ran from the masts to the sides of the ship, providing lateral support and giving sailors a way to climb aloft. Installing rigging on a carrack required specialized knowledge. Rope makers had to calculate the exact diameter and strength requirements for each line. Too thin, and ropes would snap under load. Too thick, and they'd be unnecessarily heavy and difficult to handle. The sails themselves were engineering marvels. A carrack's main course, the largest square sail on the mainmast, might be 60 feet wide and 40 feet tall. Sewing these massive sheets of canvas required teams of sailmakers working for weeks. They'd reinforce edges with rope sewn into the hem, add metal grommets for attachment points, and create multiple rows of reef points that allowed the sail area to be reduced in strong winds. Portuguese carracks were designed from the beginning to be armed merchant ships. They needed to defend themselves against pirates, hostile nations, and sometimes unfriendly locals in distant ports. This meant integrating weapons into the design without compromising cargo capacity or sailing performance. Gun ports, openings in the hull for cannons, had to be carefully positioned. Too low and waves would flood through them. Too high, and they'd be ineffective. Portuguese shipwrights developed hinged gunport covers that could be opened for battle and closed and secured when sailing. These had to be absolutely watertight because water entering through gunports could sink a ship quickly. The deck structure had to support the weight of cannons, some weighing several tons, and absorb the recoil forces when they fired. Reinforced deck beams and additional framing were built in around gun positions. The deck itself needed to be clear enough for gun crews to work efficiently, but also provide secure storage for all the equipment a long voyage required. Below decks, carracks were divided into numerous compartments and holds. The lowest level, the bilge, was where water collected and had to be pumped out constantly. Above that, the hold stored cargo, ballast, and provisions. Portuguese ships heading to India might carry goods for trade, textiles, wine, tools, weapons, as well as provisions for a crew of 200 or more for a voyage lasting 6 months or longer. Provisioning a carrack was a massive undertaking. They'd load thousands of pounds of hardtack, dry, long-lasting biscuits that were a staple of sailors' diets. Barrels of salt pork and beef, dried fish, cheese, dried beans and peas, wine, water and olive oil. Everything had to be carefully packed to maximize space and ensure even weight distribution. Fresh water was stored in large wooden casks. A carrack might carry 100 or more barrels, each holding 50 gallons or more. Water quality was a constant problem. It would become stagnant and contaminated during long voyages. Wine was actually safer to drink and lasted longer, so ships carried enormous quantities. The galley, the ship's kitchen, was a small, brick-lined area where fires could be safely maintained. Cooking on a wooden ship in the middle of the ocean was inherently dangerous, so the galley was carefully designed with fire safety in mind. Sandboxes surrounded the fire area, and water was always kept ready for emergencies. Living conditions on carracks were crowded and harsh. Common sailors slept wherever they could find space, in hammocks strung between deck beams, on coils of rope, even on the bare deck. Officers had tiny cabins in the stern castle, but even these were cramped spaces barely large enough to stand in. The captain's cabin was the most spacious, often occupying the entire width of the stern castle's top level. This served as command center, navigation room, dining area for officers, and the captain's personal quarters. It would contain navigation equipment, charts, the ship's log, weapons, and perhaps some personal luxuries. Sanitation on carracks was primitive. The heads, toilets, were located at the bow, essentially just holes in a platform extending over the water. Privacy was non-existent. Disease was rampant on long voyages, and ships often lost significant portions of their crew to scurvy, dysentery, and other illnesses before reaching their destinations. Despite these hardships, Portuguese carracks successfully completed some of the most ambitious voyages in history. The Carreira da India, the India Run, saw annual fleets of carracks sail from Lisbon around Africa to India and back, a round trip that took over a year and covered more than 20,000 miles. These ships carried spices, silks, and precious goods back to Europe, generating enormous wealth for Portugal. A single successful voyage could multiply the investment several times over. The crown, merchants, and even individual sailors who invested in cargo could become wealthy from a single successful journey. But the risks were enormous. Ships were lost to storms, particularly around the Cape of Good Hope, which earned the nickname Cape of Storms before being optimistically renamed Cape of Good Hope. Ships were lost to navigational errors, running aground on uncharted reefs. Ships were lost to combat with Ottoman vessels, pirates, and competing European powers. Ships simply disappeared, never to be heard from again. The construction of each carrack represented an enormous investment, not just in materials and labor, but in accumulated knowledge. Every ship incorporated lessons learned from previous vessels. Failed designs were abandoned, successful features were replicated and refined. By the mid-1500s, Portuguese carracks had reached their peak of development. They were the largest, most capable merchant vessels in the world, combining cargo capacity, defensive armament, and oceanic sailing capability in ways that wouldn't be surpassed until the development of later galleons and East Indiamen. Now let's talk about something that made Portuguese ships truly formidable. They weren't just cargo vessels or exploration ships. They were floating fortresses capable of defending themselves against almost any threat they might encounter. The Portuguese understood something that would define maritime power for centuries. Control of the seas required ships that could fight. Unlike medieval merchant ships that relied on escorts or hope for protection, Portuguese ships from the very beginning were designed to defend themselves and, when necessary, project military power. The integration of artillery into ship design was revolutionary, and the Portuguese were pioneers in this transformation. When I say artillery, I'm talking about cannons, bronze or iron tubes that used gunpowder to hurl solid iron balls at enemy ships or fortifications. Early Portuguese ships in the 1400s carried only small weapons, hand cannons, crossbows, and perhaps a few small swivel guns mounted on the rails. But as exploration pushed into contested waters, areas controlled by Muslim powers, hostile local kingdoms, or rival European nations, armament became increasingly important. The development of gun decks was a Portuguese innovation that changed naval warfare forever. Instead of just mounting a few guns on deck where they were exposed to weather and enemy fire, Portuguese shipwrights figured out how to mount cannons below deck, firing through ports cut into the hull. This sounds simple, but the engineering challenges were massive. You're cutting holes in the watertight hull of a ship, holes that will be just a few feet above the waterline. These openings had to be large enough for cannons to fire through, but had to be sealable to prevent water from flooding the ship. Portuguese shipwrights developed the hinged gun port lid, a wooden cover that could be opened for battle and closed and secured for sailing. These lids had to be extremely strong and watertight. They were often double-layered, corked, and fitted with multiple latches that could be secured from inside. The deck structure around gun ports required massive reinforcement. Remember, a cannon might weigh 2 to 3 tons, and when it fired, the recoil generated enormous forces. The deck beams, the hull frames, everything in that area had to be engineered to absorb these stresses hundreds of times without failing. Portuguese carracks by the early 1500s might carry 30 to 40 guns of various sizes. These weren't all identical. They ranged from small falconets weighing a few hundred pounds to massive cannons weighing several tons and capable of firing 30-pound iron balls. The largest guns were mounted on the lower gun deck, as close to the waterline as possible. This positioning served two purposes. It kept the heavy weight low in the ship, improving stability, and it allowed these powerful guns to fire into the hulls of enemy ships where damage would be most effective. Medium-sized guns were positioned on upper decks, where they could fire at enemy rigging and superstructure. Small swivel guns, called pedreros or versos, were mounted on rails around the upper decks, where they could be aimed quickly to repel boarding attempts. The logistics of operating these weapons at sea were incredibly complex. Each gun required a trained crew, typically 4 to 8 men, depending on the size. They had to load the gun with precise amounts of gunpowder, ram home the shot, prime the touch hole, aim the weapon, and fire it, all while the ship was moving and potentially under enemy fire. Ammunition storage was another critical consideration. Cannonballs were stored in racks or lockers near the guns. Gunpowder, incredibly dangerous in a wooden ship, was stored in the magazine, a specially constructed room deep in the ship, as far from potential fires as possible. The magazine had to be waterproof, fireproof to the extent possible, and accessible only through a locked door. Portuguese ships developed sophisticated powder handling procedures. Gunpowder was never carried directly from the magazine to the guns. Instead, it was placed in leather or cloth bags by specialists in the magazine, then passed through a corridor to powder boys, young crew members who would run these charges to the guns. This system minimized the risk of a chain of powder leading to the magazine. But armament wasn't just about cannons. Portuguese ships carried extensive small arms, arquebuses, early firearms, crossbows, pikes, swords, and armor. When ships closed for boarding, which was still the primary method of capturing enemy vessels, these weapons became crucial. The high forecastles and stern castles of Portuguese ships were designed with combat in mind. They provided elevated platforms where soldiers could fire down on enemy ships or repel boarders trying to climb up. Some ships had specially reinforced sections of railing that could be quickly converted into defensive barricades. Portuguese ships also carried specialized anti-personnel weapons. Swivel guns loaded with small shot could fire into groups of boarders or enemy crew. Some ships carried primitive grenades, ceramic or iron balls filled with gunpowder that could be thrown or dropped onto enemy decks. The crew composition of an armed Portuguese merchant ship reflected its dual nature. There would be professional sailors to handle the ship, but also soldiers, typically 20 to 50 on a large carrack, whose sole job was fighting. These soldiers didn't need to know how to sail. They needed to know how to operate guns and weapons. Naval combat in the Age of Discovery followed patterns that might seem strange to modern eyes. Ships would approach each other and exchange cannon fire, but the goal was usually to disable the enemy ship, bring down masts, damage rigging, kill crew, then close for boarding. The fight would often be decided by hand-to-hand combat on blood-slicked decks. Portuguese ships, with their high superstructures, multiple gun decks, and well-trained crews, had significant advantages in these encounters. They could bring more firepower to bear, their soldiers fought from superior positions, and their solid construction meant they could absorb damage that might sink lesser vessels. The Portuguese also pioneered the concept of purpose-built warships. While most of their fleet consisted of armed merchant vessels, they also constructed ships whose sole purpose was combat. These warships sacrificed cargo capacity for additional armament and crew. One thing that's often overlooked is the psychological impact of Portuguese firepower. When Portuguese ships appeared off the coast of African or Asian ports, their cannons made it clear that resistance would be costly. This show of force was often enough to secure trading rights without actual combat. The Portuguese also used their armed ships to establish and maintain fortified trading posts throughout their empire. Ships would transport soldiers, construction materials, and supplies to establish these footholds. The ships themselves could then serve as mobile artillery platforms, supporting the forts with their guns. Maintenance of all this armament was a constant challenge. Cannons had to be cleaned and preserved to prevent rust. Gunpowder had to be kept dry, a nearly impossible task on ships that leaked constantly and were surrounded by salt water. Wooden gun carriages had to be repaired and replaced. Ammunition had to be counted and secured. The cost of arming ships was enormous. A single bronze cannon might cost as much as building a small caravel. Gunpowder was expensive to produce and dangerous to transport. The additional crew required for the guns increased operational costs significantly, but the Portuguese calculated that these costs were worth it. Armed merchant ships could trade in hostile waters without needing expensive naval escorts. They could defend Portuguese interests directly, and when necessary, they could seize enemy vessels and cargo, sometimes paying for themselves in a single action. By the mid-1500s, the Portuguese model of the armed merchant ship had been copied by every European maritime power. The age of defenseless merchant vessels, depending on luck or escort, had ended. The Portuguese had proven that merchant ships could be warships, that trade and power projection could be combined in a single vessel. This integration of commerce and military capability was a defining feature of the Age of Discovery and would shape naval architecture for the next 3 centuries. Now I need to talk about something that often gets glossed over in romantic tales of maritime exploration: the human cost of building these magnificent ships. Behind every vessel that sailed into history were thousands of workers, and their stories deserve to be told. Let me start with the shipwrights themselves, the skilled craftsmen who were the backbone of Portuguese maritime power. These weren't just laborers. They were highly trained professionals who'd spent years mastering their craft. A master shipwright's training began in childhood. Boys were apprenticed to established masters, often family members, and spent 7 to 10 years learning every aspect of shipbuilding. They'd start with simple tasks, carrying tools, sorting timber, cleaning up, and gradually progress to more complex work. By the time someone achieved master status, they possessed an encyclopedic knowledge of ship design, timber properties, joinery techniques, mathematics, and even some theoretical navigation. They could look at a set of drawings, or even just describe what a ship needed to do, and figure out how to build it. The compensation for master shipwrights reflected their value. They earned wages many times higher than ordinary laborers and received additional benefits: housing, food allowances, sometimes even a percentage of a ship's first voyage profits. The Crown actively recruited the best shipwrights, offering generous terms to keep them in Portuguese service. But here's something darker. Portuguese shipbuilding knowledge was considered a state secret. Master shipwrights were often prohibited from leaving Portugal or working for foreign powers. Some who tried to leave were pursued and, in extreme cases, assassinated to prevent Portuguese techniques from spreading to rivals. Below the masters were journeyman shipwrights, skilled craftsmen who'd completed their apprenticeships but hadn't yet achieved master status. These men did much of the actual construction work. They were the ones fitting planks, shaping timbers, and executing the master's designs. Then there were the specialized trades. Caulkers, who sealed the seams between planks, formed their own guild with specialized knowledge passed down through generations. Riggers, who installed all the rope work, had skills that were equally specialized. Sailmakers, blacksmiths, rope makers, each trade had its own hierarchy and traditions. Ordinary laborers formed the base of the workforce pyramid. These men did the heavy, unskilled work, hauling timber, moving materials, operating windlasses and cranes, and performing countless other tasks that required muscle more than skill. Their wages were minimal, their working conditions harsh, and their lives often short. But I need to talk about an uncomfortable truth. Portuguese shipyards also used enslaved labor. As Portugal's African colonial ventures expanded, enslaved Africans were brought to Lisbon and other ports, and many were put to work in shipyards. The historical record is somewhat unclear about the exact numbers and roles, but we know that enslaved people worked in Portuguese maritime industries from the mid-1400s onward. Some performed unskilled labor. Some, ironically, used skills they'd learned in their homelands. African maritime cultures had sophisticated boat-building traditions of their own. The use of enslaved labor in building ships that would then be used to transport more enslaved people across the Atlantic is a dark irony that can't be ignored. These vessels, which represented human ingenuity and ambition, were also instruments of one of history's greatest crimes against humanity. Working conditions in shipyards were dangerous for everyone, enslaved or free. Workers fell from heights, were crushed by falling timber, lost fingers or hands to tools, suffered from exposure to toxic substances like pitch and tar, and endured brutal physical labor in all weather conditions. There were no safety regulations as we understand them today. A worker who was injured might receive some compensation if he was valued, or might simply be dismissed if he couldn't work anymore. The concept of employer responsibility for worker safety didn't exist. The noise in a shipyard must have been overwhelming. Imagine hundreds of men working simultaneously, hammering, sawing, shouting, with the constant background of mallets driving caulking into seams. Many shipyard workers suffered hearing loss. The smell would have been intense too. Tar, pitch, fresh-cut wood, sweat, smoke from forges, and the general aroma of a waterfront industrial area before modern sanitation. Workers would have gone home each day covered in sawdust, tar, and grime. Working hours were long, typically from dawn to dusk, 6 days a week. Sunday was reserved for religious observance, but even then, urgent work might continue. During periods of intense activity, like preparing a fleet for a major expedition, workers might labor even longer hours. Families often lived near the shipyards in cramped, primitive housing. Entire communities grew up around maritime industries, with multi-generational families all working in related trades. Sons followed fathers into shipwright apprenticeships. Daughters might marry into other maritime families. The social structure was rigid. Master craftsmen had status and respect in Portuguese society. They might own property, participate in guild activities, and have some political influence. Ordinary laborers lived hand-to-mouth, always one injury or economic downturn away from destitution. Accidents were common and often fatal. A man could be crushed by timber, fall from a ship under construction, be struck by falling tools, or suffer any number of other injuries. There was no workers' compensation, no disability insurance, and no retirement plans. If you couldn't work, you and your family starved unless you had savings or family support. Despite these harsh conditions, there was also genuine pride in the work. Shipbuilders understood they were creating vessels that would make history. They knew their ships would sail to the ends of the earth, would carry explorers to unknown lands, would return laden with exotic goods. This pride didn't erase the hardship, but it gave meaning to the labor. The communities around shipyards developed their own cultures, traditions, and identities. There were festivals celebrating successful launches, patron saints associated with different trades, and social networks that provided support in times of need. Women's roles in shipbuilding were limited by the era's social norms, but weren't non-existent. Women weren't shipwrights, but they worked as sailmakers, rope makers, and in provisioning, preparing the food and supplies that ships would carry. They also managed households while men worked long hours, essentially keeping the domestic economy functioning. The relationship between workers and the crown was complex. The Portuguese government needed skilled shipbuilders desperately, so they cultivated loyalty through relatively good pay and conditions for skilled workers. But they also maintained tight control, treating shipbuilding knowledge as strategic assets that had to be protected. Foreign workers were sometimes recruited when Portuguese labor was insufficient. Italian shipwrights, known for their advanced techniques, were particularly sought after. These foreign craftsmen brought new ideas and methods, contributing to Portuguese innovation even as authorities worried about secrets being leaked. The legacy of these workers, from masters to laborers, free to enslaved, is visible in every ship that sailed from Portuguese ports. Each vessel represented thousands of hours of human effort, skill acquired over lifetimes, and yes, suffering and exploitation. When we look at the beautiful models of caravels and carracks in museums, or when we celebrate the voyages of discovery, we should remember all the people who made those voyages possible. The explorers get the glory, but the shipbuilders made the exploration possible in the first place. So we've journeyed through 5 centuries of Portuguese maritime innovation together, from ancient Roman galleys to cutting-edge caravels, from humble shipyard workshops to massive carracks that conquered oceans. We've seen the genius of design, the mastery of craft, and yes, the human cost behind these magnificent vessels. But now I want to hear from you, because this is where your voice matters. If you were a Portuguese shipwright in the age of discovery, what kind of ship would you have designed? Would you push for even sleeker caravels that could sail faster and closer to the wind? Would you try to build larger carracks that could carry more cargo and more guns? Or would you experiment with something completely revolutionary? Maybe you'd try to combine the speed of a caravel with the capacity of a carrack. Maybe you'd focus on crew comfort, creating ships where sailors could survive long voyages more safely. Maybe you'd prioritize defense, building floating fortresses that could dominate any fight. Or maybe you'd aim for efficiency, trying to build ships that were cheaper and faster to construct without sacrificing performance. Here's what I want you to do. Hit that subscribe button right now if you haven't already, because we're going to keep diving deep into maritime history, engineering, and the stories that shaped our world. This channel is about understanding how things were really built, how they really worked, and the real people behind historical achievements. And here's the important part. Drop a comment below telling me what ship design you'd have pursued and why. I read every single comment, and honestly, some of the best insights and most interesting perspectives come from you, the viewers. Your thoughts might even inspire future videos. Would you sacrifice cargo space for speed? Would you take risks on experimental designs? Would you play it safe with proven techniques? Would you focus on exploration, trade, or warfare? There's no wrong answer here. I want to know how you think about these design challenges. And while you're down there in the comments, tell me what maritime topic you want me to cover next. Should we talk about Viking longships and how they conquered the North Atlantic? Should we explore Chinese junks and the incredible treasure fleets of Zheng He? Should we examine the Dutch East Indiamen that dominated 17th century trade? Or maybe you want to know about naval warfare tactics, or how sailors navigated without GPS, or what life was really like on these long voyages. The beauty of history is that there are endless fascinating stories to tell, and I want to tell the ones that interest you most. This channel exists because of viewers like you who share these videos, who engage in the comments, and who bring their own knowledge and perspectives to the conversation. If you enjoyed this deep dive into Portuguese shipbuilding, share it with someone who loves history, engineering, or just great storytelling. Post it in your maritime history forums. Send it to that friend who's always talking about Age of Empires. Share it with your dad who loves wooden ship models. Every share helps this content reach more people who appreciate the complexity and craftsmanship that went into these historical achievements. And honestly, it helps me justify spending weeks researching these topics to bring you the most accurate, comprehensive, and engaging content possible. Before you go, let me leave you with this thought. Those Portuguese shipwrights working in the Ribeira das Naus 500 years ago couldn't have imagined that we'd still be talking about their work in the 21st century. They were solving immediate problems. How to build ships that wouldn't sink, that could sail where others couldn't, that could bring wealth and power to their nation. But in doing so, they created objects that transcended their immediate purpose. Those ships became symbols of human ambition, ingenuity, and our relentless drive to explore and understand our world. The techniques they developed influenced shipbuilding for centuries. The voyages their ships made possible changed the course of human history. And that's what fascinates me about this subject. It's not just about wood and nails and sails. It's about human beings pushing the boundaries of what's possible with the tools and knowledge available to them. It's about craftsmanship elevated to an art form. It's about how technology shapes history and how human ambition drives technological innovation. The Portuguese didn't build ships, they built keys that unlocked the entire world. And understanding how they did it helps us appreciate both the brilliance and the complexity of our own history. So go ahead, subscribe, hit that like button, drop a comment with your ship design ideas, and let's keep this conversation going. Because history isn't just about the past. It's about understanding how we got here and maybe getting some insights into where we're going. Thanks for watching, and I'll see you in the next video, where we'll dive into another incredible story of human ingenuity and ambition. Until then, keep exploring, keep learning, and keep wondering how things really worked. Fair winds and following seas, my friends.